Jay and I will be discussing some of the watershed focused tools that we have at CW3E. So these are in addition to a lot of the forecast tools that we just described in the last session. So Jay, go ahead to the next slide. So again, we've got our objectives here of all the forecast tools. Again, I went over these about less than an hour ago, so I won't spend too much time here. The main focus of a lot of these tools is really that second objective that we have listed there, and that's the watershed forecast that aid in the impact-based decision support of water resources and FIRO. Again, we also have multi-models and ensemble forecasts in these tools as well. Go to the next slide, Jay. So here's a brief overview of some of the watershed forecast tools that we have. So in terms of that multi-model framework, we have many of the same models that I mentioned earlier, the GFS, the ECMWF, both the deterministic and the ensemble versions of those, the Westwharf, which we'll hear more about in a little bit. And then in addition to those, we are also working on implementing products using the HER, the Weather Prediction Center forecast, as well as the CNRFC forecast. So those will be coming down the road soon. For our watershed-centric tools, we have freezing level and precipitation-based forecasts for the HUC-8 watersheds over the Western United States. And then in addition to that, we also are working on HUC-10-based watersheds for QPF. And these are included, these are using a spatial distribution in terms of a mapping interface, as well as time series over these watersheds. Go ahead, Jake. So the first tool that I'll be talking about here is our freezing levels forecast tools. So both the freezing level and the precipitation tools, watershed forecast tools are set up on a sort of a similar style page. They're on an interactive maps, sort of Google Maps type interface that you see here. Basically, you can move around, zoom in, and select your watershed of interest that you would like to see the forecast for. For our freezing level forecast, the watersheds here, you can see all of the HUC-8 watersheds outlined over the Western US. The color shading on this map will be based on the percent of precipitation over the next 7 days forecasted to fall as rain versus snow. So in this example, you're seeing quite a bit of green here, as this was taken from just a week or so ago. So we don't have a lot of snow yet. But once we get into the winter season, you'll see some blues and greens mixed in here as well. Go ahead, Jay. So when you select your given watershed, you'll get a forecast image popping up similar to this. This is an example from the GEFS, which you can choose on the map as well. And then you can also toggle to the ECMWF. Go ahead, Jay. And you can also select to activate both models and see a comparison of the two here. So being able to compare these two side by side, again, Jay mentioned this earlier, it just gives you a nice way to look at the uncertainty, both among each ensemble model itself, as well as between the two ensemble models. Go ahead, Jay. So to dive in a little bit more into how these tools work, this is set up very similar to the IVT plume diagrams that Jay went over earlier. However, now instead of looking at IVT, we're looking at the forecasted freezing level. Go ahead, Jay. So all these different lines here are representative of the forecasted freezing level based on this ensemble model. Each one of the lines is the different ensemble members. And again, the spread among these lines gives us a good indication of the uncertainty within the ensemble and the forecasted freezing level. The topography within the watershed is also shown on the right diagram, as well as the horizontal dashed lines in the left diagram. One more click, Jay. Thank you. And these are shown based on a percentage of the watershed above or below a given height chosen. Good. So the other thing to consider when we're looking at freezing level is, when is the precipitation forecasted to fall? That's really when we care about the freezing level. So to look at that, we overlay the forecasted precipitation over the given watershed. So these bars are representative of the 6-hour mean aerial precipitation over the selected watershed. You can go ahead and click twice there, Jay. And the color shading within these bars represents the percent of the watershed to receive rain versus snow. So if you look at the bars sort of early on the 27th of February there, you'll notice that they are mostly filled with green. This is corresponding to a time when the forecasted freezing level is relatively high and near the top of the watershed. So seeing all that green is showing that the majority of that precipitation will be falling, or is forecasted to fall as liquid or rain over much of the watershed. If you look a little bit later in this forecast, say midday on the 28th of February, the freezing level is forecasted to drop a little below 90 down towards the 75% of the watershed. And that's where we start to see a little bit of that blue on the top of that bar. So that blue is representing the percent of the watershed that is expected to experience snow during this time period. That cyan color or lighter blue between the darker blue and the green, this is representing the percent of the watershed that is within the ensemble uncertainty. So basically how much of the watershed is between that red line and that blue line of your forecasted freezing level. So because that's within the uncertainty of the ensemble, based on this forecast, there really isn't a strong indication of whether this would be liquid or frozen precipitation. So we identify that as sort of our range of uncertainty. And lastly, at the top of these diagrams, you'll see a 7-day summary of the total precipitation, as well as those percentages of rain versus snow and the uncertainty associated with that. So I'll turn it over to Jay now to talk a little bit about our watershed precipitation tools. Okay.
Yeah, so with the upcoming water year, we're going to be making a little bit of changes to the way we visualize the mean aerial precipitation forecasts over the different watersheds. We're focusing on the Huck 8 sized hydrologic unit codes over California, which is shown on this map. That's the same as we've done in the past. We calculate the mean aerial precipitation from the global models. Last year, we showcased the GFS deterministic, the ECMWF deterministic, and we also threw on the national blended models from the National Weather Service for comparison. This year, we are going to be calculating the mean aerial precipitation from those models averaged over these Huck 8 size domains from not only just the deterministic GFS and the ECMWF models, but also their ensembles. And so what I'm showing you here is an example. It's the same interactive JavaScript mapping page that we use for our freezing levels. So you can zoom in, you can zoom out, you can pan left and right over California. You can select your different watersheds that you're interested in, or at the very bottom, you can see some buttons for the Russian Feather, Yuba, and Santa Ana. Hopefully you know where the watersheds are, but if you don't, you can click on those and it'll snap right to the watershed that you want. We're also providing some of the quantitative information, also an interactive table, so you can sort by the watershed name alphabetically, or you can sort based on things like the 5- and 10-day precipitation. Again, these are providing situational awareness for the amount of precipitation upcoming in the forecast. You're probably making decisions based on sub 8 Huck 8 time scale, sub Huck 8 watershed scale, but this is pretty good first pass of how much water is expected to fall with our bigger systems like our atmospheric rivers. We also pull up a plume diagram here of the precipitation. The cyan color is the 6-hour precipitation of the ensemble mean. And each one of the traces here in gray are the different ensemble member accumulations on the right axis, with the control and ensemble mean forecast highlighted in the dark colors. So for this precipitation forecast, which was initialized on October 8th last week, it was predicting 0.23 inches of rain averaged over the entire upper Yuba Huck 8 watershed. We can compare that with, oh, sorry, this is a video. I'm hoping that it comes through, but it's just a demo of the interactivity of the web page that we're developing. It has no sound, so you shouldn't be hearing anything, but hopefully you can see things moving around on their own. All right, so I'm assuming somebody would have said something if it wasn't showing. So that's just a demo of some of the interactivity that we're going to be putting on our QPF page for the Huck 8 watersheds. We also are going to be showcasing how the QPF compares with the integrated vapor transport averaged over some of the watersheds. This is something that's in development for this water year and probably just only be available in an experimental capacity for AR reconnaissance. But here's an example. This is from a forecast from today. So I do have the ability to run these on a case-by-case basis. So we selected the upper Yuba watershed in the interactive map here. We can bring up the maximum IVT or the precipitation or the time integrated IVT, and you can see the IVT plume diagrams right alongside the QPF diagrams. So this sort of goes back to the conversation that we were having earlier this morning. I did mention to you that we might be making decisions based on smaller scale precipitation distributions, not the Huck 8s. So in an experimental capacity and specifically for past events, we're looking to map some of our higher resolution precipitation forecasts onto the Huck 10s, which is the next step down in size. This is an example of the precipitation distribution from a forecast prior to our January 2021 landfalling AR event. I've selected the upper North Yuba River Huck 10 watershed, and you can see the deterministic reservoir forecast in the lower right part of the diagram. We also hope to bring online being able to look at the CNRFC QPF forecast grids, the HER forecast grids, and maybe some of the other high resolution models so that you can see them all in the same framework, all from within the same interactive place on our website. And then the final piece is we also want to bring in the observations of precipitation, snow level, the distrometers, the microrain radars, the soil moisture, and our ARO observations for our different FIRO watersheds across California. So you can not only see what's been going on in the past, but what's going to be going on in the future. And so this is an example of an interactive page that we're developing with Anna, where you zoom in on the FIRO watershed of interest. This one happens to zoom in on the upper Yuba and also the Feather watersheds. And you can see all the different symbols representing the different types of observations that CW3E has on its website. What you're looking at after you click on that surface met soil site here and the Feather is the observations from the Feather River College showing the temperature, relative humidity, pressure, solar radiation, precipitation, soil moisture, and soil temperature. And so we're sort of just trying to aggregate a lot of our observational information within the different watersheds all in one place.